Hello world! In this episode I want to talk about this book, the biography of Elon Musk. And I want to tell you why I'm a huge fan of Elon Musk. Because, in my opinion, he's just the master of multidisciplinary engineering. In this book you will find several examples of how crossing the boundaries of predefined businesses, predefined spaces of expertise can lead to a dramatic improvement, mainly in cost reduction, but while keeping the same functionality. One good example is from Tesla. As probably most of you know, in the Tesla you have that huge 17-inch touchscreen. And while they were developing the Tesla, they were looking for an automotive supplier able to provide them this touchscreen, and all suppliers turned them down and told them 17-inch touchscreen capacitive in a car has never been done before, we can't supply that. So, following his basic rules, which is rely on basic principle, a very, very important rule, which means that you look at the physics, you look at really at the laws of physics, for example, that you can assume are fixed, and everything else is derived from that, but therefore not absolutely fixed. And given. So they just took a screen from home electronics and tested it as if it was an automotive screen. And then they realized, hey, it works. That screen that was meant to be used in a home environment, we can also use it in the car environment, which is a more harsh environment. Of course, you have greater temperature range, you have higher accelerations, g-forces on that whole PCB, but it worked. And so they realized that they can by themselves put that automotive certification on top of it, because they realized it's definitely reliable enough to be used in a car. And going even a step further, they did the same for SpaceX. In SpaceX they used components they developed themselves, or they bought from suppliers who were not certified as aerospace suppliers, and they could reduce their cost by orders of magnitude. Because the established suppliers, especially if it comes to space crafts, the established suppliers for NASA and the other space companies, they knew they were in a very comfortable space, they had made all the tests, the certifications needed, so they could barely charge anything they wanted. And so there's anecdotes of having a quotation from a trusted supplier for aerospace technology who was asking for $120,000 for a component, and Elon Musk just saying his engineer, look, you have a budget of $5,000. And in the end the engineer came up with a solution for about $3,500, because it is possible. So it is very important to look what exactly is inside. If it's a touch screen, probably the screen part is made somewhere in Asia in a plant, and it's highly probable that the screen is the same whether you use it in a home environment or you use it in a car environment. It comes out of the same manufacturing line. Okay, the testing was not the same, and I know as an engineer it's very important to do in-depth testing of the components, because it can become very, very costly if something breaks in the middle of the way. But especially looking at electronics, at PCB manufacturing, the standards are about the same everywhere. I mean, you have to really be very, very harsh to a PCB until you get to a point where your components get ripped off the board by G-forces, for example. And usually the chips are made in a very, very standardized process. So the variation in quality between different chips is minimal. And so often the chip that is made for home use or for car use is also very usable if you go out in the space. And the second point is, if you can use these mass-produced chips that were made for home entertainment, and you have to make some industrial solutions, you're usually close to a point where you can just take 2 of them or even 3 of them and use them in a redundant way, and you're still cheaper by orders of magnitude compared to the finished and certified solution that is offered by the specialist in your field. So read that biography if you haven't yet. I'm a huge fan, and that's how I see multidisciplinary engineering in automotive and in aerospace technology, as shown by example by Elon Musk. Subscribe, like, comment. I'm very interested in your feedback, and see you next time.